Hey, welcome back to Math with Patrick and Quill. Today is November 22nd, and we're solving problem 326 from the Daily Epsilon calendar. And we should hope to find the answer 22 today, because that matches today's date. It looks like a medium difficulty geometry problem. We have this isosceles triangle here. I note that these two angles are the same, so therefore these two sides are the same. And we're just trying to find the area of it, and hopefully that area is 22. We do have a kind of weird side length here. This is the fourth root of 3,872. Again, because the triangle is isosceles, we could stick that length over here as well. Part of me is kind of interested in seeing if I can simplify this fourth root at all, and I just have a calculator with me. I'm basically just first checking how many 2's I can divide out of it, and I got 4 of them. Cool. So this number is actually the same thing as the fourth root of 16 times the fourth root of 242. And then the fourth root of 16 is 2 because 2 times 2 times 2 times 2 gives you 16. So I could think of this number as 2 times the fourth root of 242 instead. And then maybe this will be nice later just because I have a smaller number underneath my radical. And something kind of interesting about this problem, so this 45 degrees right here is going to essentially fit perfectly in an octagon. We could multiply that 45 degrees by 8, getting 360 right here. And that just shows that we could stack 8 of these, or I guess rotate 8 of these triangles around and just get a perfect regular hexagon. Of course, my lines aren't that straight, so this diagram isn't perfect, but it gets the point across. And so all of these triangles that I'm drawing are equivalent, or I guess congruent, to the one that we have here. And so technically it is possible to think of this problem in terms of like regular octagons if we want, but I think I just have an easier strategy. I'm basically just going to find the area of a triangle the normal way, doing half times base times height. I'm going to call this my base, and then it's important that the height is perpendicular to the base. So this is going to be my height right here. The base is just this number, although I think I will opt for my slightly simpler number after I reduced this radical. And the height is a little bit hard to find. However, not too hard. We do have a 45, 45, 90 triangle right here. And these triangles have a relationship where if you know the hypotenuse, you just need to divide by root 2 to get one of the legs. Or if you had information about the legs, you could multiply by root 2 to get the hypotenuse. Here, however, we are starting with the information of knowing the hypotenuse. And so I can just take my hypotenuse number, which I guess again is still this, and divide it by root 2 to get information about this leg right here. And so that number is going to be 2 times the fourth root of 242 divided by root 2. And so this number right here, hopefully, simplifies to 22. I think what I'll do first is just collect up kind of my non-radical numbers. Everything here is just being multiplied or divided, so I can kind of do stuff in whatever order I want. So grabbing this 2, that 2, and the 1/2, I do get a 2 out front. Then I am left with the fourth root of 242 times the fourth root of 242, and then all divided by root 2. This fourth root times a fourth root, I know just gives you a square root. The idea is that if you have a fourth root of something, just by definition, it means that you can multiply 4 of them to get the thing underneath the root sign. However, if we combine this and this, I know that it's just the same thing as a square root times a square root. Again, just kind of by definition of square roots, that if we take a square root and multiply it once over, we get the thing underneath that square root sign. So I can simplify that numerator quite a bit, actually. Just instead of 2 fourth roots, we could just call it the square root of 242, still divided by that root 2. I'm just kind of moving this 2 wherever I want for now. And then with square roots in a fraction, you are allowed to, instead of doing a ratio of square roots, you're allowed to do the fraction first, and then square root that. 242 divided by 2 is 121. and then 121 is the square of 11, or in other words, the square root of 121 is 11. Multiplying these together, we do get 22, and that is today's date and the area of our triangle. So there's my solution, basically just doing a little bit of like radical arithmetic with triangles, though I think it is possible to try to solve this problem thinking more about octagons instead. But I just opted for a pretty standard, triangle area formula. So we're all done for today. Thanks for watching, and I'll see you tomorrow. Bye.